I'd be glad to answer a question for where to start. If you look at this problem, the first thing you want to do is recognize what are we mixing here. You're mixing, it gives you a volume and a molarity of a strong acid, and it's mixing a volume and molarity of a weak base. And I want to write this chemical reaction first. Before you figure out the pH of the solution, you need to know what's in the container, what's actually floating around. And since these will react with each other, I can't just start by using these numbers and getting my pH. I have to start by reacting these. And you should start with a chemical reaction between your strong acid and your weak base. And what happens for the chemical reaction is the weak base acts like a base. It takes this proton, and when it takes that proton, it becomes this. And the thing that's left over, it's floating around, is chlorine. We don't care about this. This is neutral. So the thing that you care about is how much of this is produced and how much of this is left over. It's going to react until one of these completely runs out. And if you do the math here, 0.1 times 70, we have 7 millimoles of this. And 100 times 0.2 gives me 20 millimoles of this. So the HCl is going to run out. This will go to 0. And this will go to 13. And then that means as this reacts, we're going to go from 0 here, there's none of this to start, and we're going to add 7 to this side, and we'll have 7 millimoles of this. So you want to take these values, millimoles, these guys right here, they need to be converted into concentration, and once they're converted into concentrations, then you can set up an ice box for this equilibrium, just for these two in equilibrium, and dissociating to produce the proton. Use the Kb or Ka, however you set up your equilibrium. If you start with this on the left, you're going to have the Kb expression. If you start with this on the left, you'll have the Ka expression with these starting concentrations. Or you could use the Henderson-Hasselbalch equation. I hope that helps. If you still have questions and I need some help for the next step there, I'd be glad to help you. I'll just write that next equation for you so you know what that looks like. If this is floating around in solution, this is, if you're going to do the base way, treating it as a base, it's going to donate a proton, or steal a proton from your H2O, so it would be this. And you would have your concentrations here and here to set up your ice box for initial and figure out how much OH is produced. Hope that helps.